Video for January 13th through the 14th. Let's go ahead and get started with a few simplifications. Simplify these three here. We'll do them one at a time. First off, if we have only a single term with a radical in the bottom and it's a square root, you can just multiply by that same square root. If it's something more like a cubed root, you need to multiply by another cubed root, but you're trying to get the bottom to be a perfect cube, so it won't be an identical radical. You'll have to adjust it so that you get a perfect cube. But for this one here, we got square roots, so square root of 3 to the top and the bottom. Whatever you do to the top, you do to the bottom. This is a form of 1, so it doesn't actually change the value. And we get 6 root 3 all over 3. But then the top and the bottom can be divided by 3, and we would just get 2 root 3. All said and done with this one. All right, when there's two terms on the bottom and one of them is a square root, you can just multiply by the conjugate. So 1 minus the square root of 2. Whatever you do to the bottom, you do to the top. I showed you what to do if this was a cubed root. It's a much more complicated conjugate that you could go look up if you really needed, but as far as testing quizzes go, I'll only do square roots in the bottom like this. Now we're going to FOIL on the bottom, and we will get, on the top, it's just going to be 1 minus root 2. But on the bottom, we'll get 1 times 1 is 1, minus root 2 plus root 2, and then square root of 2 times a negative square root of 2 becomes just a minus 2. All right, now these terms cancel out, and 1 minus 2 becomes just a negative 1. So I've got 1 minus root 2 all over negative 1. And then I'll distribute that division, and when you divide by negative 1, you just flip the sign, so this becomes negative 1 plus root 2. All right, and our last one, this cubed root here, I'm trying to remove perfect cube factors. So it's useful to write down some perfect cubes, like 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Let's see, 27 does not fit into 56 evenly. 8 does. 8 times 7. With the negative, a negative can just jump out. So now I've got negative cubed root of 8 times 7. And then with the x to the 4th, write out all 4 x's. And then you need to make a group of 3 to break out of a cubed root, and a single x can come out. Same with the y's, write out all 5 y's. And again, they can only make one group big enough to break out. Let's break this 8 out as well. And we'll get negative 2xy on the outside times the cubed root of 7x, and then these y's go back together to become a y squared. Okay, one more simplify. Here we've got a cubed root over a cubed root. 54 does have a perfect cube factor. I can split that 54 into a 27 and a 2. All right, that 27 can then break out and become a 3. So I get 5 cubed root 2 over 4 times 3 cubed root 2. And I can cancel out those cubed root 2's because it's the same on the top and the bottom. And I'm just left with 5 over 12, final answer. So here's a case where you could have used the quotient property of radicals to put this together into a fraction. It wouldn't have helped you because 2 over 54 can't be simplified down to a single integer. You could have gotten it down to 1 over 27, but then you would have ended up taking it apart again into 2 radicals. So don't always distribute or factor out a radical. Sometimes you want to look for a different way to simplify it. Okay, goal for today is to be able to solve equations involving a radical and some resulting in a quadratic. This is going to be another chance to use quadratics, and we'll introduce the idea of extraneous solutions. So if I've just got a square root equals a number, I'm allowed to square both sides. And I'll get n equals 1 here. Plug it back in, it works, that's our solution. So that's a squared cancels out a square root. Here, the entire side isn't underneath the radical, so before we square both sides, let's just subtract 1 from both sides. And now we've got the square root of -6 minus 8 equals 2. All right, we just isolated this. So isolate the radical. Then we're going to square both sides. And I showed that it's just a caret 2. Those carets look a little funny. All right, and so let's write what we're doing here. We are squaring both sides. All right, when this side's all underneath the square root and then I square it, the square root and the squared cancel out, and I get -6 minus x equals 2 squared is a 4. Now I've got a nice linear equation I can solve. I can add 6 to both sides. I get -x equals 10, divide both sides by -1, and get x equals -10. Now you have to double check these answers because the squared root can cause you to pick up extraneous solutions and you won't really even know. But we can do this in our head. I plug in a -10 here. This negative flips it back to be positive. This becomes the square root of 4, which is a 2. 2 plus 1 equals 3. 3 equals 3. It does work out. But always double check because you can get extraneous solutions. All right, when I have radical equals a radical, this is another pretty easy case because I can just square both sides, and now they're no longer radicals. Now it's just r plus 7 equals -2 minus 2r. But because they started as radicals, again, you have the potential for extraneous solutions. So you have to plug your answer back in and double check that you're not either taking the square root of a negative, which we're not allowed to do, or having a square root become a negative, which we're not allowed to do. All right, so let's get our r's together by adding 2r to both sides. We now got 3r plus 7 equals -2. Let's move our constants away from the variable. 3r equals -9. Divide away any coefficients, and we get r equals -3. If I plug that in there, this becomes a 4. Plug that in there. This side becomes a 4 as well. Square root of 4 equals square root of 4. That does balance. 2 equals 2. So this is a good solution. All right. Now, radical equals a variable. This actually gets a little bit more tricky because this is where we start picking up quadratics, is if you've got just a variable over on this side. The radical is already isolated, so I can square both sides. And I'll get 12 minus n equals n squared. There's my quadratic. How do I solve quadratics? Well, I do it by setting them equal to 0. So I'll add n to both sides. 12 equals n squared plus n. Subtract 12 from both sides. 0 equals n squared plus n minus 12. And then see if this factors. Are there two numbers that multiply to be -12 but add to be +1? There are, +4 and -3. And I get n equals -4 and n equals +3 by the factor theorem. We can just say that's factor theorem, something we learned back in Unit 4 on polynomials. Let's check these now. So if I plug in the -4, I'm going to get the square root of 12 minus a -4 equals -4. Square root of 16 equals -4. 4 equals -4. Again, when we start with a radical, we only keep the principal square root, so we only keep positives. And so this doesn't work. This was an extraneous solution. Extraneous. But let's see if 3 works. Square root of 12 minus 3 equals 3. Square root of 9 equals 3. 3 equals 3. This side did work. So we got one good solution and one extraneous solution. And sometimes you get 2 extraneous, sometimes you get 2 good, sometimes you get 1 extraneous, 1 good. There is really no pattern to that. The 2 answers are just pretty much independent of one another. Okay. Now, here we've got square root equals square root, but with the addition of another number in there. here's what we're going to do. We're going to isolate one radical, then we're going to square both sides, then we're going to isolate the other radical, and then we're going to square both sides again. And that's how we're going to be able to get rid of both of these radicals. All right, we cannot isolate them both at the same time, so you got to do them one at a time. So this side's already isolated, so I can square both sides. But on this side, imagine a set of parentheses around this. When I square this, it means take the entire base and multiply it by itself. So it's actually going to get pretty big. It becomes the square root of 9 minus 5x minus 3 times that whole thing again, because it's being squared. And we're going to pick up some extra terms, because we're not allowed to just distribute our squared. And then on this side, it just becomes a negative 2x. All right, so here this needs to be FOILed. These are binomials because the square root is gluing all of this together. That means I can simplify it by doing first outside, inside, last. And I get, when I multiply just these radicals, it's as if I'm doing the square root of 9 minus 5x squared, because I'm multiplying it to itself. And the square root and the squared can cancel out. Then I do outside, and I get minus 3 root 9 minus 5x. Then I do inside, I get another minus 3 root 9 minus 5x. And then I do last, and I get a positive 9. It's negative 2x. Let's see, I can add 5x to both sides here. And then combine some other terms. This 9 and this 9 can become an 18. These have the matching radicals, so I can just combine their coefficients, get a negative 6 root 9 minus 5x equals, and then on this side I added that 5x, this becomes a 3x. All right, so we're on to isolate the other radical. So let's just keep moving things away from this radical, and we'll be able to get it by itself. So negative 6 root 9 minus 5x equals 3x minus 18. And divide both sides by negative 6. And I get the square root of 9 minus 5x equals, well, it's negative 1/2 x plus 3. Second, I didn't think that this one ended up with a fraction. It could, but that's a good time to double check I haven't made any mistakes. So that's, yep, definitely a negative 3. That becomes positive 9. Add that over, we get a 3x, combine these, 6. Yep, okay, so let's just keep going with that fraction. Going to square both sides, and I get 9 minus 5x equals, so imagine set of parentheses here, got to FOIL this out, I would get a positive 1/4 x squared minus 3/2 x minus 3/2 x plus 9. And now got to solve this quadratic. Make my life easier by just multiplying everything by 4. So I don't have any fractions left. And I get 36 minus 20x equals x squared. This becomes 12 over 2, so minus 6x minus 6x plus 36. Those 36's can cancel from both sides. Get now negative 20x equals x squared minus 12x move that 20x over, and I get 0 equals x squared plus 8x. You can factor in an x here, so 0 equals x times x plus 8. And I get x equals 0 and x equals negative 8 by factor theorem. And then we definitely want to plug these back in to double check. So I plug in a 0, I get square root of 9 minus 3 equals, this becomes 0, so 3 minus 3 equals 0, so that one's good. If I plug in a negative 8, this one's a little bit harder, we got 40, so 49, so that becomes a 7. 7 minus 3 is a 4, and then the square root of 16 is a 4, so this one works as well. They're both two good solutions, 0 and negative 8. All right, I'll embed a few more questions for you here, and that's that for this video. Have a good rest of your day.